welcome you all to our brilliant channel Maths Nation. Dear students, if you have not subscribed Maths Nation, kindly subscribe it now. Please press the bell icon to get the notification of the upcoming videos. Students, I promise you to complete your syllabus and I would like to solve all your queries which you may kindly drop in the comment box. Dear students, in my last sessions we have discussed about circle. Today we continue with this. The circle. The theorem says, here the theorem 6 says, two chords ABAC of a circle are equal. Prove that the center of the circle lies on the angle bisector of BAC. Suppose this is a circle. Suppose this is a circle. Suppose this is a circle and two chords ABAC of a circle are of equal. AB and AC. AB and AC are two chords of the circle of equal length. AB is equal to AC. Then the next condition says, prove that the center of the circle lies on the angle bisector of BAC. Here we have to prove that the center of the circle lies on the, suppose this is the angle bisector of BAC. Then here we have to prove that the center O lies in this angle bisector. Then here construct joint BC. Joint BC. Joint BC. Then suppose the joint BC and it intersect the angle bisector at M. And here is the point AD is the angle bisector. Then here the theorem says, given ABAC are two chords of the circle. Here given AB is equal to AC. Two chords of the circle, two chords of the given circle, and next says, thus prove that construct then BAD is the angle bisector. AD is the angle bisector of BAC. Angle bisector of angle BAC. Then here to prove that the center O lies on AD. Okay. Then prove. Next, keep it here. The next proof. Here consider the triangle, draw the angle bisector AD which join the line BC at M. Then here consider the triangle BAM and CAM. Here the AD is the angle bisector which join the BC at M. Here AD the angle bisector, join BC at M. Then consider the triangle, BAM, and triangle CAM. Consider the two triangles. Here AB is equal to AC given. Then AM is equal to AM common side, and angle BAM is equal to angle CAM since AD is the angle bisector. since AD is the angle bisector. Then this angle is equal to this angle, as AD is the angle bisector of BAC. Here this side is equal to this side given, and this is the common side. This angle is equal to this angle. Then by I say here, then by SAS property, SAS property, side angle side property, triangle BAM is congruent with the triangle CAM. Okay, then triangle BAM is congruent with the triangle CAM. This means BM is equal to CM by CPCT, and angle BMA is equal to angle CMA. This angle is equal to this angle, but BMA and CMA are linear pair. But angle BMA and angle CMA are linear pair, which means this means these two angles are equal and these two angles are linear pair. This means angle BMA is equal to angle CMA is equal to 90 degrees. Since they are linear pair, sum of their measure is 180 degree. Their sum is 180 degree and they both are equal. This means angle BMA is equal to angle CMA 90 degree. Here BM is equal to CM. These two angles are 90 degree. This implies AM is perpendicular to BC. This implies AM is perpendicular to BC, which shows that the AM passes through the center O, which shows that this keep it here. This shows AM passes through center. AM passes through center, as we know that the line passes through the center is perpendicular to the chord. The line which passes through the center of the circle, hence proved. This is, we have to prove that the center O lies on AD. Here we get this shows that the AM means AD, the angle bisector, passes through the center. Since it is perpendicular to the chord BC, the line passes through the center is only perpendicular bisector of the chord. This means this is passes through the center of the circle, hence proved the theorem, hence proved. Okay, hence proved. Then next vice versa. Look at here the theorem says ABAC are two equal chords of the circle where AD is the angle bisector. We have to prove that the angle bisector passes through the center. Then here we join the angle bisector, join BC, and here the two triangles ABM and CAM. Consider the two triangles BAM and CAM. Here these two triangles are congruent. Then BM is equal to CM by CPCT, and angle BMA is equal to angle CMA is 90 degree, which shows that AD is perpendicular to BC. As AD is perpendicular to BC and this is bisector of the chord, AD is the perpendicular bisector of the chord BC, which shows that AD must passes through the center C. Okay. Then next, vice versa. Here the theorem says, if if this is a circle, and this is the center, look at here, this is center, and AB here, two chords AB and AC of a circle with center O. Here O is the center, and AB, AC are two chords AB and AC. A, B and AC are two chords of the circle and are such that O lies on the bisector of angle BAC. And here this is the angle bisector. This is the angle bisector of the angle BAC. Here AO is the angle bisector of the angle BAC, and the center lies on the angle bisector. Then here we have to prove that AB is equal to AC. Here join BO and CO. Here join BO and CO. Here join BO and CO. Then two chords, we have to prove that the two chords AB is equal to AC. Here the given conditions, here the theorem says given AB and AC are two chords, AB and AC are two chords, and AO is the angle bisector, of angle BAC. Then here angle BAC, angle bisector, which shows that angle BAO is equal to angle CAO. Then here to prove that, here we have to prove that AB is equal to AC. These two chords are equal. We have to prove that. Proof. Here OA is equal to OB. Since radius, both OA and OB are radius, then in triangle OAB, angle OAB is equal to angle OBA. Since isosceles, these two sides are equal, this shows that this angle will be equal to this angle OBA, since isosceles. Then here in triangle OAC, OA is equal to OC, which shows that angle OAC is equal to angle OCA. These two is this side are equal since radius. OA is equal to OC since radius. Both are radius. This implies OAC is equal to OCA since isosceles. These two sides are equal, which shows that this angle is equal to this angle since isosceles. And given that AO is the angle bisector, which implies BAO is equal to CAO, then this shows that, keep it here, this shows that here angle OA, look, this shows that angle OAC is equal to angle OAB is equal to angle OAB is equal to angle OBA is equal to angle OCA. Okay. Here, look at here. These two angles are equal. here these two angles are equal, and here these two angles are equal. This shows that this angle is equal to this angle is equal to this angle is equal to this angle. Then consider the triangle OAB here. Consider triangle OAB and triangle OAC and triangle OAC. Here OA is the common side, equal to OA, common side. Then angle OAB is equal to angle OAC, and angle OBA is equal to angle OCA. Then by angle side, then by AAS property, angle side, AAS property, triangle OAB is congruent with the triangle OAC, which shows that AB is equal to AC by CPCT. These two triangles are congruent, which shows that AB is equal to AC by CPCT. Okay. These two, AB is equal to AC by CPCT, hence proved. Okay. Then solved some questions. I have already told you, only knowing the theorem is not sufficient. Practice variety of questions. You students, please do your worksheet and ask me your doubt. Here the question says, here the example 1. The radius of a circle is 13 centimeter given. Here this is a circle, and whose radius? This is the center, and this is a chord, and here the radius is, this is center, and this OA, the radius is 13. Then L is the perpendicular, here OA is the radius, L is the perpendicular, and length of the chord is AB is equal to 10 centimeter given. Find the distance of the chord from the center. This means here given OA equal to 13, the radius OA, the radius is 13, and length of AB chord is equal to length is equal to 10 centimeter. Then here we have to find out the distance of the chord from the center, means we have to find out the length of OL. Then here consider the triangle OAL. Then in triangle OAL, it is a right triangle. It is a right angle triangle. And OA is the hypotenuse is equal to 13, and AB is equal to 10. This implies AB is equal to 10, which implies AL is equal to 10 by 2. Since the perpendicular from center, the perpendicular always bisect the chord. Since the perpendicular from the center, bisect the chord. Then AL is equal to 10 by 2, which equal to 5 centimeter. Then by using Pythagoras theorem, OL is equal to OA square minus AL square root. By using Pythagoras theorem, P square P is equal to H square minus B square square root. Then this OL is equal to OA square minus AL square. OA 13 square minus 5 square square root, which equal to 169 minus 25 square root, which equal to 144 square root, is equal to 12 centimeter. Means distance of the chord from the center OL length is equal to 12 centimeter. Then next question. The next question says here, example 2 says, find the length of the chord which is at a distance 5 cm from the center of the circle of radius 13 cm. Here the question says, radius of the circle is here, this is a chord AB and this is center of the circle and radius is given 13. Then length, distance, this is the center and distance of the chord from the center is given 5 cm. Then here we have to find out length of the chord. Here OA, the radius is equal to, here given the OA, the radius is equal to 13 cm and OL, the perpendicular distance is equal to, the perpendicular distance is equal to 5 centimeter. Then here we have to find out the length of the chord AB. Then here AL square, by using Pythagoras theorem, AL square is equal to OA square minus OL square square root, which equal to 13 square minus 5 square square root. 169 minus 25 square root, which equal to 144 square root, is equal to 12 centimeter. Here AL is equal to 12 centimeter, which imply AB is equal to 2 into AL, since AL is equal to half of AB. As we know that the perpendicular from the center is always bisect the chord. This means which is equal to 2 into 12 is equal to 24 centimeter. Then here length of the chord AB is equal to 24 centimeter. Okay students, today this much. In my next sessions we will continue with this. Happy New Year. Thank you students.